Now in this part, now after this part, we'll start studying about the paleomagnetism. Okay. So we have studied about the seafloor. Now we'll study about the paleomagnetism. Now in this paleomagnetism, what you see? See, by magnet itself, you can see that in this part we'll be seeing some concepts regarding the magnetic. So this part of the paleomagnetism, it was given by Vince and Matthews. It was given in 1963, just after the seafloor spreading theory. So what do we mean by the paleomagnetism? Paleomagnetism is the study of the records of the Earth's magnetic field with the help of magnetic fields recorded in the rock sediments or the archaeological materials. Okay, so like what we studied that, see here, suppose when we have the volcanic eruptions, the properties of magnetics, so the magnetic properties, what will happen in this set? Suppose if this is A, okay, this is also A. So what will happen? These both will having the same magnetic properties. Okay, these both will be having the same magnetic properties. Then if you see this particular part, if you take it as the B, okay, if you take it as the B, so what will happen? These two also will be having the same magnetic properties. But what will happen? They'll be having the different magnetic properties than this A. Okay, they'll be having the different magnetic properties than A. So what will happen? Like when these lava at the younger age, okay, when we have the formation of this particular belt. So when they are the younger lava, so what will happen? That time they will having the normal magnetic fields. Okay, normal. Like see, if we are studying about the Earth, so what will this? We have the north south. Okay, so this is what geographical north and the geographical south. Okay, and this geographical north and south, these are what? These are the fixed point. Okay, these are the fixed point. It won't change. But whereas if you see the magnetic properties, okay, this north and south, what will happen? This north and south can be reversed. It can be reversed. At later stage, it might become this as become as south, and this might become as north. And this will happen in like millions of years. It will happen in millions of years. So these reverses will be seeing in this particular part. We have the reverse magnetic field. So there what will happen? Like what will happen? This newer lava will having the normal magnetic field. Okay, and older lava will be having the older surfaces will be having the reverse magnetic field. Okay, rocks formed from the underwater volcanic activity are mainly basaltic. We know that they are having the low silica and they are the iron rich. Okay, so that will be making up to the oceanic floor. So now in this part, first it will be like normal direction, north south. Okay, then as it becomes old, so what will happen is direction will change. Okay, the magnetic field's direction will change and it will become south north. Okay, so here what will happen? The reverse processes will be happening in this part. Okay, so in this part, what happens? There the paleomagnetism takes place. Okay, the polarity of the Earth's magnetic field, what will happen? That will reverse. Okay, the basalt contains the magnetic minerals, and as the rock is solidifying, these minerals align themselves in the direction of the magnetic field. So these minerals, these basaltic minerals, what they'll do? They'll align themselves in the direction of the magnetic field. This locks in a record of which the magnetic field was positioned at the time. So what do you mean the paleomagnetic? It studies the rocks of have the demonstrated that the orientation of the Earth's magnetic field has the frequently alternated. Okay. So in paleomagnetic, what will be seeing that is like frequently it is changing. Okay. So geomagnetic reversals over a geological time over a time it will be being reversed. Okay. So because of that, for that only we are studying this particular paleomagnetism. The polarity of the Earth's magnetic field and the magnetic field reverse are thus. So this polarity of the magnetic field. Polarity means what? That north and south. It will be of same. When it reverses, it will become south and north. Like okay. So thus detectable by studying the rocks of the different ages. Okay. So by studying the rocks of different ages, we are able to study this reversal of this magnetic field also. Okay. So in this particular paleomagnetism, it can be seen by the various evidences. Okay. various evidences we can study this particular paleomagnetism. So in this paleomagnetism that led to the revival of the continental drift. Okay, this paleomagnetism led to the revival of this continental drift hypothesis. Okay, and the transformation of transformation into theories of the seafloor and the plate tectonic. So like we saw about that all those rocks of same ages. Okay, so in that also this paleomagnetism helps. Like in the while studying about the continental drift theory, we saw that in the South America part and the Africa part, we are having the rocks of same ages. So all those things, so that gave the revival of this paleomagnetism, gave the revival of continental drift theory also. Okay, the regions that holds the unique record of the Earth's magnetic field lies along the mid-oceanic ridges. The unique record of the Earth's magnetic means what? Normal, the polarity will be normal. That will be nearby to the mid-oceanic ridges. That will be nearer. Okay, at nearer place. Okay, where the seafloor is spreading. On studying the paleomagnetic rocks on either side of the oceanic ridges, it is found that alternate magnetic rock stripes were flipped so that one stripe would be having the normal polarity and the next will be reversed. So what will happen? This particular rocks will be having a normal polarity, then other will be, this particular will be reversed. So they will be reversed. Okay, and they will be having a normal polarity. So in this way, by this studying the rocks of the same ages, we understood this paleomagnetism. Okay, so hence paleomagnetic rocks. Okay, so paleo means what? Denoting rocks. On either side of the mid-oceanic, on the submarine ridges, provide the most important evidence of the concept of the seafloor spreading. So that's how these paleomagnetic rocks provides the evidence for the seafloor spreading. Okay, so magnetic field records also provide the information of the past location of the tectonic plates. So in that way, this particle also gives the location of the tectonic plates. Okay, so this now in this explanation, if you see like oceanic ridges are having boundaries. Okay, and like we in that also we saw that diverging boundary and also the converging boundaries. Okay, so diverging is what they will be moving apart, and converging is what they will be colliding. Means what? They will be attracting each other. Okay, they will be colliding. The fissure or vent in between the ridges between the plates allowed the magma to rise and harden into a long narrow band of rock on the either side of the vent. Okay, either side of the vent. And there what that's what we studied, that on the either side of the vent we'll be seeing that these two are having the same magnetic properties, and these two rocks, the older rocks, are having the same magnetic properties. Okay, so these are things regarding this particular paleomagnetism. Okay, so the alternate patterns will be seen in the older rocks and the newer rocks. Okay, the alternate magnetic properties will be seen. So this is all about the paleomagnetism. This is all about the paleomagnetism. And who gave this paleomagnetism? It was given by Vince and Matthews. Vince and Matthews in 1963. Okay, so we have finished the different theories of this particular part regarding the earth formation. Now we'll study about the plate tectonic theory. Okay, so regarding this plate tectonic theory, we'll study in the next class. Okay, so tomorrow morning, if we do not have the class, math class, during that time we'll study about the plate tectonic theory. Okay, so regarding this particular part, regarding all those theories, you all tell me, do you all have any doubt regarding all theories? We studied about the continental drift theory. We studied about the seafloor spreading theory. We studied about the convectional current theory, and we studied about the paleomagnetism. So anyone, any doubt in this particular part? In tomorrow class, we'll study about the plate tectonic theory. And after it, only we'll be able to understand that how that plates always moving. Okay. So that we'll study in the tomorrow classes. And there we'll be studying about that Eurasian plate, African plate, North American plate, that how led to the formation of continents. So all those parts we'll study in the tomorrow morning classes, suppose if we don't have the mathematics class. So tell me, anyone having any doubt in this particular part? Taken? Okay. Okay. So tomorrow we'll see about the plate tectonic theory. Okay, and after seeing about the plate tectonic theory, then after it we'll start studying about the types of rocks, and then we'll start, after studying about the types of rocks, also we'll study about the mountains. Okay, types of mountains, then volcanoes, types of volcanoes. Then after that we'll move for the landforms. Okay, and also we'll study about the earthquakes. So all these parts we'll study in our later classes. So tomorrow morning, just I'll confirm from Gaurav sir. Then after that, I'll tell you all, I'll inform you all in the group. So thank you all. Jan, you all can leave the class now.
Thank you, sir.
Thank you.